1, 2, 3. Hello, today's video I want to talk about the measurement of variability in statistics called population variance and population standard deviation. So what is population variance? The definition of population variance is average of the distances from each data point in the population to the mean squared. So let's actually look at the equation of the variance and see what this actually does. So this is equation for the variance. This is n(i)(1) xi minus the mu of squared divided by n. Okay, as you can see here, xi stands for each data in the data set. So mu, this is the mean, so as same as the average, and n is the number of data. So what we actually do is we calculate the sigma, means the summation. So we calculate average distances of each data point to the mean squared. So let's take a look at the examples for what variance value can tell us. So suppose there are 2 classrooms in the school that has 5 students each. So let's say there's class A, and class A students' heights are 180, 182, 183, 185, and 185. And of course, unit for the height is centimeter, and class B has the height of 153, 166, 192, 194, 210 centimeter. Okay. To actually calculate the variance of something, we first need to calculate the mean. So we are going to calculate the mean for both classes. To calculate the mean, we are going to add up all the data and going to divide it by the number of data, which is 5. So here 180, so this is for class A, okay? 82, 183, 185, and 185 is, I've already calculated it, and it is 915. And we need to divide it by the number of data, right? Number of heights. So it is going to be 183 centimeter. This is average height of class A. This is A. And we are going to calculate the mean for class B. This is 153, 166, 192, 194, and 210. So this is going to be at same as class A, 915, and divided by 5 is 183 centimeter heights. So this is the class B. So both classes have a same average height, right? So you might be tempted to say, when you just know this information, that both classes approximately have a similar height. But is it really? So let's look at the scatter plot of class A and class B. So classroom A is in the pink dot, classroom B is in the green dot. Although both classes have the same average height, class A students' heights are clustered around the mean, right? It is very close to mean that each data in the classroom A is. But when you look at the classroom B, students' heights are really far from the mean. If you look at it here, it's really far, right? So I don't think we can say the data, so heights of classroom A and heights of classroom B is really similar in terms of variability. So, but this is all good, but it would be good if there is a numerical value that can tell us, variability in the data set. So that's what population variance does. So let's actually calculate the population variance. To calculate the population variance, I'm going to use this equation. So for the classroom A, let's start it in the different page. Classroom A has the, what height was it? It was 180 centimeter, 182, 183, 185, and 185, right? So we are going to subtract the mean from each data point, and we are going to square them. This is the first data, first height, you might say. 182, the second data, second height, and carry on. 85, 83 squared, 185, 183 squared. And this is going to be -3 squared, and this is going to be -1 squared. This is going to be 0 squared, this is going to be 2 squared, and the rest is the same. So if we calculate it, -3 squared is 9, -1 squared is 1, 0 squared is 1, 2 squared is 4, and 4. And if we add all them up, it's going to be 4 plus 4 is 8, and 10, 19. 19. And what do we need to do? We need to divide it by the number of heights, right? It's a 5, so 3.8. And what's the unit for this one? So unit for the height is centimeter, right? But because we squared it, it's going to be centimeter squared. So this is the variance of A. When you just look at this variance, you can't really tell much about it. Is this big or not? We don't know. So let's calculate a variance for the B as well. So B has the 153, 166, 192, 194, and 210. Let's draw the line here. So we are going to do the same thing as we done in the classroom A. It's going to be 153 minus the mean of the classroom B. And we are going to do this for all the data in all the heights in the classroom B. And then let's carry on. 94 is 103 squared. So now this is going to be minus 30 squared. This is going to be minus 17 squared. This is going to be 9 squared. This is going to be 11 squared. This is going to be 27 squared. And if we calculate it, this is 900, and I need to calculate this 17 squared. 17 squared is 289. 9, this is 81. This is 121, and this is 27 squared is 729, right? So if we add all them up, it's going to be, I've already calculated this, 2120. And what do we need to do? We need to divide it by the number of heights in the classroom B. So this is going to be 424 centimeters squared. Remember, this is centimeter squared, not just centimeter, like in the height. So now if you look at it, what did I tell? Variance tells us that variability in the data set, right? So variance of A is 3.8 centimeters squared, whereas variance of B is 425 centimeters squared. Which one is greater? Obviously, this variance B is way more greater than variance A. So we can actually say with the numerical value that there is much more variability in the group classroom B. So therefore we can say heights in the classroom B is much more spread out than classroom A's heights. Okay. All right. So for the next one, so you might be wondering now, this isn't very intuitive result. Why? Because we square the distances of each data point to the mean, the unit of the variance is centimeter squared, right? Not centimeter. So it's not as same as the unit in the height, which is the centimeter. So when you actually say variance in group A is 3.8 centimeters squared, you can think, so what does this mean? Is it really big or is it really small? You can't say much about it. So that's why we need standard deviation. So let's see how we calculate standard deviation. So standard deviation's equation is, we are going to follow all the equations from the variance. So this is standard deviation. There. Then what is variance? Is this squared, right? So what is different? There is no squared. So what do we need to do? Remove the squares. So we give them a square root, right? So this is the equation for the standard deviation. So why would this be more intuitive than variance? Because it will have the same unit as the unit in the variable. So if you think about it, in group A, the variance of group A was 3.8 centimeters squared, right? So what will happen is if we give the square root to this variance, it will become, so let me calculate it real quick. 3.8 is 1.94. 1.94, and then because of the square root, this square will be gone and becomes centimeter. So now we can say the standard deviation in group A is 1.94 centimeter. So it actually seems like the variability in group A is really small. Because we have the same unit, it is more intuitive, right? So, okay, this is it for the population variance and standard deviation. If there is something you guys don't understand, please leave the comment down below and I'll try my best to answer those. Thank you.